Okay, so we're going to do that. I'll do one example, you do your turn, and then probably we'll take a break and come back. And then I have a more advanced problem below. I can skip that. Don't have to do that today if necessary for time. Okay, so when you have this little notation that they give you, let me write these functions down. You take the function on the right, you put it into the function on the left. So you go from right to left. Now people sometimes make mistakes because we read from left to right, so we might react to the first thing we see. Okay, but this notation for the example, this does not mean M go into N. This means the other way around, N go into M. That's what that means. And I'll just point out again how to think about it in a second. So basically, this came from dropping all those parentheses. So that meant you were putting the N function in. Now I'm using brackets because to me it's more visually pleasing. So we just drop all those pairs of parentheses and we replace the circle. All right, so we're going to replace the N function. We're going to replace this X with the rule X minus 1 over X plus 2. So we're replacing that right here. And then we're going to get a yucky fraction, but that's just how it is. So this composite function, replacing the X with the N rule. So X minus 1 over X plus 2, and then over now it always depends upon what you get as to the strategy. In this case, we want to get rid of these complex denominators. Right? That's kind of complicated, although that is true. So I'm going to multiply top and bottom by X plus 2 and then simplify. All right, so here you're going to remember the distributive property. This plus the fraction then times it should be 3. Okay, so then X minus 1, and then 2 times, I won't try to go too fast. And then on the bottom, again, X minus 1, and then 3 times. Okay, and then you could do probably some more in your head. So X plus 2X, so that's 3X. And then minus 1 plus 2 times 2, so that's plus 3. And then on the bottom, X plus 3X, so that's 4X. And then minus 1 plus 3 times 2, so that's 5. Okay, so now the domain issue. Well, before we simplified this, there would have been a domain issue when X plus 2 is 0. And that's because the original function, that was a domain issue. So we check the original function's domain issue, and then we replace it into the other function, and then we check the composite function's domain issue. Okay, so already we got X cannot be negative 2. So the domain consists of X's such that X cannot be negative 2. And then the composite function's domain, there's another issue. All right, if you put this equal to 0, that means X cannot be negative 5 over 4. Or X cannot be negative 5 over 4. And so that would be the complete domain statement for the composite function.